So good morning everybody. Fred already said everything for me. Today we will see a research that I carried out during my 6 months research time in Israel with Professor Shohab here. And it's about the maintenance of culverts, kind of structures that were not very known for me at the beginning. So, what is a culvert? A culvert, as many of you may know, is those kind of structures that allow the water to flow underneath roadways and roadways also, and also to allow the animals to go through obstacles. There are many kinds of culverts in terms of materials and shape. And in this research we will focus on concrete-based cast in situ culverts, box-shaped and bridge-shaped. The problem in Israel is that culverts represent key nodes of the water transportation. The water is very precious, especially for the desertic areas, where this resource needs to be transported. And culverts, as they are not well maintained, don't allow the water to flow and to be brought in these areas. The state of Israel, as one of the biggest records, recognized that these assets do not receive the attention they deserve. So they need to be proper maintained compared to other roadways and other request assets like pavement and bridges. As you can see here, the culverts are seriously damaged, and this happens mostly during the peaks of water flow. During those times, the water flow gets very strong, and many stiff objects like rocks and debris can hit against the culvert and damage the culvert itself. Also, slow water flow can damage the culvert, but this is at a low level. Another thing to remark is that damage of the culvert can also happen because of chemicals. Indeed, if not proper geotechnical investigations are made and the concrete mix design therefore is not well suitable, the degradation of the culvert because of the chemicals and also of the environmental condition speeds up very much during the life cycle. Therefore, culverts are in need of proper maintenance because the current practice is that of rectal maintenance. And, this kind of maintenance policy has the drawback to have unplanned repair works and an interruption of the serviceability while making works for repair. We come to our research objective. That was to develop a method to determine which is the optimal maintenance strategy for these assets. The methodology is developed in 4 steps. At first, we carried out a field survey to determine 2 key parameters, the age and the culvert performance. With these 2 parameters then, thanks to regression analysis, we found an exponential deterioration pattern. We used the deterioration pattern to develop the transition probability matrix, the basis for the prediction of the market chain process. And we determined life cycle performance and life cycle maintenance cost that we combined together in an indicator called the maintenance effectiveness indicator that gave us which is the optimal life cycle maintenance strategy. The survey that we carried out conveyed the size of 36 culverts all across Israel. So we had an idea of which are the conditions in the north and in the south to have a better idea. As you can see here, basic parameters included which is the road, the kilometer, the length, width, and height of the culvert, and then year of construction, from which we determine easily the age, and then the culvert performance. For the culvert performance is a little bit tricky. Let's see how we did. We basically found a good method to assess the condition of the structure in the condition indicators algorithm from the bridge condition indicators volume. In this volume developed by Sterritt, there is a very suitable representation and method to assess structure. In this methodology is used by the UK Service for Maintenance of Grid Structure, so it's recognized at the national level. According to this procedure, you have to establish the component importance at first, and then determine the component condition score, highlighted in red. That is visually assessed by the user, and it gives a score from 1 to 5. From these two indicators, then there are developed other 3 indicators, as you see in the graph here, and this is done for each component of the culvert, which I'm going to see in detail. And eventually, there is the structure condition score, which gives an idea of the culvert performance according to the performance of each component. So, the component condition score is based on the severity extent method. It's also in the volume that I was speaking before. Extent codes and severity codes are provided for the component investigated. The combination of these components gives the component condition scores, and you may know that here it was given importance more to the extent of damage. So, sorry, to the severity of damage compared to the extent of the damage itself. Because if we analyze row C, for instance, which is a moderate damage, 5 to 20%, you can see that in case 1, the score is 1.1, which is a good condition, where 1 is the best, and it easily gets very worse the condition 2.1, 3.1, 4.1 as the severity of the damage gets higher. Here there is an example how to assess the culvert condition score. This is a basic culvert where we can recognize 9 components: the ceiling, the floor, the enclosing wall, number 3, the forehead wall, joints, wing wall, safety railings, road, and slope. So these components, all of them, have different category importance. This importance is very high, medium, and low. How this importance was assigned? Well, at first, the main, the key parameter is the stability of the culvert itself. Therefore, you see the ceiling and the floor, because constitutes also the foundation in case of box culvert, has very high importance. Then it's about safety. So enclosing walls, forehead wall, joints, wing wall, and also safety railing contributes to the safety of the culvert and of the traffic. Therefore, these components have high importance. Eventually, the road and slope can have medium and low importance. Not in all culverts these components may be present, but they were mostly present in all the culverts that we surveyed. I want to make you know that components 6 and 7, 6, 7, and 8, safety railing and road, are under concrete components. You may say that we could have done road category, but the thing is that in many culverts, the road and the safety railing may be done of concrete, so they follow the concrete degradation, and also it was to make the method simple but not simpler. Here are the 36 culverts that we surveyed. comparing the Cooper performance and the HTTP parameters. As I said, 1 indicates good performance, while 5 and 4 are bad performances. We studied 3 models, the logarithmic, the linear, and exponential, and we found the exponential to be most significantly, with a high level of correlation. As you can see, R² is 0.94. Therefore, we can say the sample was large enough to obtain a suitable deterioration model. Also, we tested the Gaussian distribution thanks to T-squared test, and we found there is a 92% of probability to be a normally distribution. And in this distribution of probability, as I said before, we found the transition probabilities inside the matrix. Now let's get to point 3 of the methodology, the Markov chain. To remind you briefly, a Markov chain is a kind of stochastic process where the prediction of the process is based solely on the current condition. The changes of state of the system are called transitions, and the probability associated with the state changes are called transition probabilities, and they're collected in what is called the transition probability matrix. Each probability is less than 1, and for each row, the sum of them is 1, therefore 100%. Go ahead. Markov chains models have 2 major advantages compared to deterministic models. The first is that they are able to consider the randomness due to uncertainties in initial condition, in load stressings, and most of all in the iteration process. Moreover, as I already said, they only consider the current condition in predicting the future condition. And they also have been found to be very practical in dealing with large-side networks and very efficient and useful for their simplicity, relative simplicity, I would say. Now I want to make a brief literature review in order to make you understand how these models are employed currently. Many studies claim that prediction of bridges and structure of roadways can be assumed as a Markov process. However, in many countries, like for Israel, Europe, and China, this method is not very well recognized. I remember Finland, probabilistic Markovian models are used at the network level. Also, New York, California, Belgium, and Sweden employ past conditions, but not Markovian models recognized at the regulation level as a regulated standard. I want to examine just 5 words, not too many, so we can see which is our contribution. If you look at this work, modeling bridge iteration of the Markov chain, it describes a method for determining and utilizing Markov chains in the evaluation of highway bridges deterioration. Here, the transition matrices are developed for condition rating of individual bridge components. The case study evaluated the expected value of condition rating. And the Markov transition matrices here are only introduced to determine repair policies. No comparison of maintenance strategies was carried out. In maintenance optimization of infrastructure networks using genetic algorithms, here Markov chain was used to predict the performance of infrastructure facilities. An optimal set of maintenance alternative was formulated for a network infrastructure facilities. The genetic algorithm is able to choose between do nothing, repair, replace, according to the facility condition state. And as a case study, they propose the 4 groups of bridge decks. The work of Nicola et al. They developed a Pulver information management system, which is able to prioritize the Pulver maintenance according to their need to be inspected, rehabilitated, or replaced. Here, a financial model was employed for the development of the derivation model, and such model is based on the remaining value of pulvers and the user cost of failures. The system here was also able to perform maintenance of pulvers for a given budget. In this work, the Markov process has been used to predict the deterioration curves for 3 concrete bridge elements: deck, girder, and abutment. Data from 5,000 bridge and curves has been used in the routing forecasting curves. Markov chain offer a suitable approach for forecasting deterioration using the set data analyzed according to the users. However, they suggest to employ Bayesian network to approach the random nature of the inspections because it will offer more reliable deterioration prediction of bridge components. Here, this last work, a simplified empirical Markovian model was used to predict the homogeneous transition probabilities of flexible pavements based on the traffic loading. Life cycle average distress rating, DR, and life cycle cost are considered. Also, cost effectiveness ratio, this was defined as the ratio of the life cycle average distress to the life cycle cost, so they put in comparison these two indicators. The cost effectiveness ratio is used to determine the optimal replication strategy between superior performance and inferior performance. So to sum up, from the visual tool that we saw here, and also from the other one that I didn't show but is present, many aspects are considered: life cycle assessment, effectiveness indicator, comparison of the deterioration strategies, and decision making. However, they consider this aspect not altogether, but maybe 2, 3, 4 of these aspects, mostly for bridges. Pulvers are okay bridge structures, but they need to be properly evaluated. Therefore, the purpose of our methodology is to convey all these aspects together and obtain an effective decision-making method that allows us to determine how to properly intervene for pulvers disasters. Let's go back to the mathematical formulation. From the deterioration model, the red line, the exponential deterioration model that we did before, we determine the transition probability matrix for 1 year. So according to the Gaussian distribution, we make formulation, or we make an evaluation of how the pulver state would be after 1 year. And you can see here that if we are in state 1-2, there is 88% that the pulver will remain in the state 1-2, and 12% it will go to 2-3. The transition probability matrix P enters the basic formulation of the model for the prediction of the life cycle performance. The model is based on an ergodic theory. That means that concerns the average behavior over time of systems in general. I, the life cycle performance matrix, provides the likely performance condition at which the pulver is expected to be found after 50 years of maintenance, according to the maintenance policy MB. The life cycle, we simply use ISO formulation for buildings and structures in general. The maintenance policy, as defined by us, is one between these three: breakdown maintenance, performance-based, and preventive maintenance policy. Let's study in detail shortly each one of these. The breakdown maintenance is a policy according to which the restoration of a damaged structure is carried out only at the end of the service life of the structure, therefore when the functionality is compromised. This maintenance strategy is often implemented for those structures that do not require proper maintenance, doesn't need any funds to plan budget. Here you can see that each state is being led to be in the current state unless it reaches the worst condition for 5. Therefore, it has to be restored. And then again, the policy will be applied until the pulver reach the end, the worst condition. We define also a performance-based maintenance in order to evaluate behavior of keeping the coolbed above the chosen level of performance. According to this policy, in general, maintenance operations are carried out only when the asset performance no longer meets the required needs and the previously agreed levels. Compared to the breakdown maintenance, this policy allows for a better use of resources and funds, of course, and reduces also the uncertainty regarding maintenance costs in a long-term time frame. The preventive maintenance policy instead has the purpose to extend the service life of assets, carrying out minor repairs and very frequent in order to delay the need of total reconstruction or a renewal. And for each coolbed component, the coolbed is being restored to be in the meter level 1, 2, as you can see according here in the matrix. The maintenance program is scheduled over a certain time frame so that the structure and its components can be optimally managed. And the application of preventive maintenance program has found to extend the asset service life in many studies. So here we have on the top the 3 maintenance policy that we just saw, and using the formula that we proposed here, they become life cycle performance matrix. The distribution, you can see, almost converges to the stationary distribution of the process for a life cycle of 50 years, because the rows are very similar. If n would be infinity, each row would be the same according to Markov and Gaudic formulations. The matrix pi is used to determine the life cycle performance, which is a scalar value. And to do so, we need to average along the column the matrix and multiply with an inner product for the performance vector. The performance vector is nothing else that averaging the coolbed condition between 1 and 2, therefore we have 1.5 and 2 and 3, and etc. You can see here that for the breakdown maintenance, the life cycle performance is 2.88, and this gives an idea of what is the performance across the average performance after 50 years of maintenance using the breakdown maintenance policy. For the performance-based preventive maintenance, it's 2.25, and the preventive maintenance is 1.62. You can see these numbers are very different because of the nature of the maintenance policy. Now let's study the life cycle maintenance cost. The life cycle maintenance cost is given as the sum of averaging the product between the pi matrix and the C cost matrix times 10, because the cost matrix is formulated for 5 years. We determine this cost matrix in shekels, but we will see the results also in dollars. For the concrete matrix, cost matrix were determined for each of the coolbed components, as we saw before. Concrete components, joints and ceilings, and flow and slope stability components. This because to carry out works on these categories, a different kind of resources and workmanship are needed. Therefore, the life cycle maintenance cost had to be calculated differently. The cost matrix takes into account the cost of material, the workmanship, special equipment if needed, and also average indirect cost due to the closure of road and traffic arrangements. Here we see an example how to determine the life cycle cost for the breakdown maintenance and for the concrete components. The cost expressed in the metrics are already in dollars, and you can see that multiplying by the pi metrics, the life cycle cost is $478,000 over 50 years of maintenance, according to breakdown. This is quite a relative high figure, but it's proven by the maintenance and other research that we found for the assets across Israel. Here we can see summarized the life cycle maintenance cost for each of the three category components and for each maintenance strategy. I would say, note that the ratio between the breakdown maintenance and the preventive maintenance is 7.05. So the resources, money needed for carrying out breakdown maintenance are 7 times the ones needed for preventive maintenance. So as the life cycle cost is not enough to understand which is the best optimal strategy to maintain the culvert, we need also life cycle performance, and we combine these together with a maintenance effectiveness indicator according to this formula. Simple formula, but gives an idea of how it works. We can see here that preventive maintenance outcomes the results of breakdown maintenance, and performance-based gets very close to breakdown, according to what we have formulated. Also, for each of the category, the trend is very, very similar. So as a result, we can say that the preventive maintenance strategy is the most cost-effective for all the components, and so for the whole culvert. This policy allows to reduce the number of breakdown events and perform cost-effective maintenance. Also allows to plan within budget so that resources are known in advance. You can see here the ratio between the maintenance effectiveness indicator for preventive and breakdown maintenance for 5 and 50 years. So you can see that preventive maintenance is more effective on a life cycle scale, as it is 13.6 times more effective than breakdown. We saw before that we spend 7 times the resources using breakdown maintenance, but preventive maintenance is 13 times in terms of effectiveness, because we also consider the performances. So this method was relatively easy to propose, and this easiness makes it suitable to be employed for other similar assets. Also, with this research, we wanted to make the state of Israel aware about these assets, which need maintenance and other kind of assets that are prone to deterioration. As a further developments, we are considering to build an automated database to prioritize maintenance of culverts, as already done in the research, and also extend this methodology to other research areas like public facilities, residential areas, and other kind of structures. So that was it. Thanks for participating. I hope you enjoyed it.
Okay, thank you very much, Consigliere. Do we have time?